All right, so it's 4 o'clock. We have to start. Thanks for coming. I've been dreaming about speaking at Voxxed Days for 2.5 years. Now I'm here. Yay. So we'll be talking about common libraries. By the way, I would like to mention that I didn't use any I when I was preparing this talk. I hope you appreciate that. So I would like to start with what you won't learn today. So you won't learn how to implement a common library in your team, in your project, all right? Because everybody has different contexts. However, I will be happy if you get some couple of useful insights that you can bring to your projects when you're back at work. Shortly about me, I run training in Spring Boot architecture, DDD, TDD, and other stuff. My name is Vadzim. I'm a co-owner and instructor at Tech, where we do those training. And I work as well as a hands-on architect at Apotek One. Apotek One is the biggest pharmacy chain in Norway. And some facts about my private life. I have a family. I live in Norway, so I don't have choice. I enjoy nature, skiing. I like to play the guitar and sing. I enjoy fishing, working out. I love cars and making some goodies for my family. And I like to do almost all of those things with my family. So my motivation was to speak about the topic that I actually developed a common library at Apotek that several projects have used for 3 years now, successfully, no problem at all. And I saw different approaches at different places, different conferences, and sometimes I thought like, okay, I could do it a bit better. That's why I would like to share my personal experience with you. So what we'll address today? First of all, we'll talk about when we need to share our code, because maybe you don't need to do this at all. What not to put to the shared code, structure of the solution, integration with Spring Boot, kind of the main part of the topic. We'll be talking about documentation, because everybody loves documentation, and how to make changes, and we'll talk about how to spread the library across the teams. Okay, so let's start with when we need to share our code. And this is like a just a pure experience. It wasn't taken from any kind of book. So what I think should be like the biggest motivators to share the code. So first of all, you need to have multiple projects that try to solve the same technical problems. If you have one, probably you don't need to, it's too early to share the code. And you're tired of copy-pasting the same solutions across projects. So you implemented something in one project, then you see, oh, I need to implement the same in another project. Oh, I need to implement the same security concern in the third project. And you're tired of just copy-pasting, and then you fix something there, and you need to copy and implement something in another project. So you're tired of it. Then probably it can be a good sign to move to this common library. And the shared code costs less than repeating it. Because sometimes when teams are really kind of separate, actually you don't need maybe to share any code between them, because maybe it will cost more to synchronize all the changes. Maybe they can just grab something from your repository and just continue on their own. And the last one, people agree to use standardized approaches, which means that people should see the value. They should understand, okay, we really need it. So if you force just, you have to, then it can be kind of problems with that as well. So you should have all of those four, okay? 4 things, then probably it's a good start. If you have only 1 or 2 of them, then it can be a bit challenging. And I made myself as well regarding these points. And it's quite hard to actually follow all of those four suggestions. So I'm guilty for introducing some common code that is not used by anyone. Okay, so the next one. What not to put in the shared code? Do you have any ideas? What not to put? Business logic, exactly. So let's imagine you have a product in one project or one product. Okay, let's call it project, and you have a product entity in another one. And some of the common ideas could be, oh, let's create an abstract product and put it somewhere in a common place, and we'll extend it and we'll benefit because we want to follow dry, yes, don't repeat yourself principle. And over here is not like anything, is not anything about following it dry or not, because if you put this abstract product inside your common library, then you should hear this sound. So it's you opening a Pandora box, right? So it won't stop. It will just bloat, and it will just more and more. People will code by example. They will just add more abstract things and things like that. And one day, one person can just will come to you and say that, you know, in my project, I would like to benefit all of those stuff from the abstract product. However, this functionality should work in another way. And you will get an idea. Oh, I will provide you another constructor, or I will add you some ifs. Yeah, as I said, Pandora box. Yeah, we shouldn't put business logic inside common libraries. Maybe you have some exceptions. I haven't seen them. However, just exceptions, just proves the rule. Next one, unstable features. Let's say you put something in a common place, and then you deliver it, but it has some bugs. Then we all create bugs, right? So then you have just get a new bug. Could you please fix it? Yes, of course. And everyone is happy. Then you get a new one, the third one, the fourth one, and then people get just reluctant to use your common library because it's buggy, it's unstable, right? That's the thing. So unstable features shouldn't be put into common place. Next one, expectations. So I expect that in the future, new projects will benefit from it. This is the common confusion, all right? So your expectations should stay inside your current project. Let's just incubate, let's wait, and then maybe in some future, when one project needs exactly the same functionality, you will think about moving this to a common place. Okay, so your expectations are your expectations, nothing else. And the fourth one is ego or desire to help, which means that many of us have different intentions. Maybe someone just wants to show off. Someone maybe wants to just help just as much as we can. Just put all my ideas and be really helpful. Some maybe want to be the most valuable person in the company. Yeah, and this is where we just add more and more code. Is it like a free lunch to have more code? If it just exists and nobody touches it? It's not free lunch. We need to maintain it. We need to upgrade the frameworks, upgrade the libraries, and it's a maintenance cost, right? So we shouldn't put this stuff into a common place as well. So you should prefer just having as little code as possible, actually. So it's actually more difficult to restrict yourself to put additional code than to write code there. Okay, so now let's go to the structure of our library, which we implemented, and how we integrated with the Spring Boot. So I would like to present 5 rationales that we had in mind before we started. So the first one, the library should be easy to include. Basically, you define a dependency in your Maven POM file, and that's it. Nothing else. Next one, developers should be bothered by the configuration of the library. Okay, so it should be easy to use as well. Anybody is familiar with that, what I'm presenting now? Please raise your hands. Just to check how old I am. Yeah, those XML, nice configuration, good days. You configure all the beans with properties, then custom those annotations with custom namespaces, So we should avoid that. The next one, it should be possible to use only specific modules. If I don't want to bring the whole cow in my house, if I want to just have a glass of milk, yes. So in this case, I would like to selectively to choose what I want to use, not the whole our common library. The library structure should follow and provide some guidelines as well. So it shouldn't be a completely mess in different parts of this library. It should follow some predefined structure. And our code doesn't always depend on Spring framework. We love Spring, but we would like to have some clear abstractions, clear for our colleagues. So if you take a look at the root level, it looks like so. It doesn't mean that you should follow the same approach, but as you can see, only technical concerns are included there. No business stuff, just some observability, some DDD concepts, from tactical DDD, search, things like that. Nothing related to the business. Then if we take a look at the root POM XML, the parent one, so it has some shared properties. Everybody can use it. I mean, all the modules can use some shared properties. Then plugin management, where we define what kind of settings the plugin will run with if you use it in your module. Then some default plugins. So we use Spock framework. In our case, it's Gmaven Plus and Checkstyle because we need to compile Groovy. So those plugins will be used by default by all the modules. Dependencies with their versions as well. So you avoid specifying versions of your dependencies every time you define some dependencies in your module. And just default dependencies like logging, right? Logging usually just enough, just to define logging and that's it. Everybody will use logging. Okay. So now let's go on the module level. So it was like a common structure. Now we are on the module level, and then on the module level, we define the following submodules. The first submodule is core, where we define some clear abstractions. All right, just nothing related to any specific frameworks like ORM, Spring, just clear abstractions. Usually a handful of classes. Next one is module Spring, where we have some implementations related to Spring that actually help us using this module. The next one is Spring Boot Auto Configure, where we define auto configurations and properties. And the last one, so the arrows actually show the dependencies. And the last one is Spring Boot Starter, which defines default set of dependencies. So it's just enough to include Spring Boot Starter and you're done. So you have all the dependencies you need. And this is a common structure of any module inside the library. By the way, after some time, you realize that module Spring and Spring Boot Auto Configure could be one module as well. So basically, technically speaking, you don't need to separate them. However, this structure was just inspired by reading a lot of source code, of Spring code as well, source code, and other libraries. So that's we came up with this final structure. So example. Let's say we have some CQS, and we have core with a handful of classes, Spring, implementation using Spring, Spring Boot Auto Configure, auto configurations, Spring Boot Starter, this is what you usually depend on in your client project, and we have as well Spring Test. Sometimes, so it's not obligatory, but sometimes if you need to write some tests that uses your abstractions, probably you need some helpers. Just some helper classes. That's why we provide Spring Test as well for those cases. Okay, so now let's go on the level below, like a core and Spring. And in this case, I took observability as an example. So we have on the core level, as you can see, we have just a handful of classes, nothing else, just really like a four files. Yes. And on the Spring level, we have as well one package which has implementation using the Spring framework. So that's an example of observability. Auto-configure. We define some auto configurations like a micrometer observability auto configuration and default observability auto configuration. And over here, it's important to take a look at this part, at the optional dependencies. Are you familiar with Maven optional dependencies? Someone probably is lazy just to raise their hands. Yeah. If you're not familiar, I just definitely recommend going to the Maven documentation and read about optional dependencies. So why do we need optional dependencies? If our dependency drives the decision of which auto configuration to use, we need to define it as optional, because otherwise it will be brought as a compiled dependencies to your client project, and we want a client project to define which dependency to use. So if a client project defines, I want to use micrometer, then micrometer observability autoconfig will be used. If the client project doesn't define anything, then micrometer won't be included as a dependency, and a default auto configuration will be used. Okay, so if you have this dependency that actually influences which auto configuration will be used, then this dependency should be optional. Okay. So, and Spring Boot Starter, as you see, it consists of two PUA files, just pom.xml and readme. And pom.xml defines what actually will be delivered to the client project if the client project decides to use Spring Boot Starter. And we deliver Spring Boot Actuator with micrometer tracing and the bridge OpenTelemetry. This is what you get by default when you use the Spring Boot Starter. Okay, so that's the thing, and about the structure. So now let's talk about auto configurations. Anybody maybe have experience with writing auto configurations? Then you probably should familiar with auto configuration annotation. Yes, and let's talk about the difference. So if you create auto configuration, you should use this annotation, but we have configuration annotation as well. Huh? Yeah. So let's just talk about the difference. So when to use what? So if you have a configuration, just ordinary configuration, and you have a service A that depends on service B, you can just call a local method to get access to service B. And Spring by default will create a proxy, and all those local calls will be proxied, and the same instance of service B will be returned all the time you call this local method. And this can some let's say consequences when it comes to performance, because to create proxy, to run this additional code, it just takes some time. In this case, but when you use auto configuration, those proxies won't be created. And in order to get access to the dependency, you need to declare it as a parameter to your method. So that's the difference. Yeah. So if you create auto configurations, please use the auto configuration annotation. If you have many of them, it will work slightly better. And it's kind of idiomatically correct today to do this. All right. As well, in addition to auto configurations, we should use conditional annotations. So what do? They actually create a new bin instance if you don't have an existing one, maybe defined by your client project. Okay? So in our case, and you may have different conditional annotations, like conditional missing bin, conditional on missing class, and other things. Right? So in auto configuration, by default, we should put conditional annotation on our bins, just to make sure that they are created only if you don't have that bin in your application context. And when it comes to overriding bins, we follow the following, let's say, structure. Auto configurations define default bin instances. So if your client configuration doesn't define any bin, it will be picked from the auto configuration. If your application defines any bin, it will be just picked from it. You don't need to use any specific annotation like primary, nothing else. You just define bin and you're fine. However, if you need to redefine it once again in the test code, then you use the primary annotation. So this like a 3-level of overriding the bins work for us in 100% cases. If you need like a 4-level, I would say that probably you should think about your design. Maybe you're overcomplicating something, all right? So 3 levels should be enough. And you want to make sure that your auto configurations run after ordinary configurations, because if not, then Spring will see your auto configuration and will check. Oh, this bin should be created only if the instance doesn't exist. Okay, it doesn't exist. I will create a new one. But maybe you will have another configuration that will run after this one with that bin. So you need to put auto configuration in the end of the list. That's why you define this file and you specify your auto configuration. Fallback. So it's a quite new annotation in Spring. I think from Spring 3.4, as I remember. So how does this annotation work? It's basically very similar to conditional missing bin. In this case, as you can see, the first movie catalog will be picked by Spring just by default if you define it. And if you don't define it, then the second movie catalog will be picked by Spring. And you may think, oh, but this is the same like a conditional annotation. Can I use it for my configurations? So technically you can. However, idiomatically it's incorrect. So fallback should be used for other stuff, like maybe multi-module setup. So like in your configuration, you have just one bin, which is a fallback. And then if you need to redefine it for whatever reason, you just define it in another module. So for auto configurations, prefer conditional annotations. It will be idiomatically correct. Yeah. By the way, I've never seen the need for fallback annotation in my life, and I have, I think I've been using Spring for like around 20 years from Spring version 2. Yeah. So. Yeah, but some people needed it, so that's why it's there. And test bin, it's a new stuff as well. So if you need to redefine your bin on the test class level, then you can define a static method that will create this service, and Spring will pick it, but only on the test class level. One more way of redefining the bins. Good. Code quality. Let's talk a bit about code quality. So we would like to reduce maintenance costs because we are not that big team. That's why we are focused on code quality and preferably automated code quality, not just manual checks. So what do? We use editor config for code formatting. Are you familiar with editor config? Okay, not that many hands. Really nice tool. It's just one text file, and a lot of IDEs are compatible with it. You don't need to do any extra configuration. You just define it, and if you use IntelliJ IDE or other IDEs, it will just pick it and use it. And you can just share it, commit it as in your Git repo. It's a really nice tool. Check style and error prone, just to adhere to some coding standards. ArcUnit, I'll speak about it in a second, and Sneak for automated vulnerability scans. So Apotek One is the biggest pharmacy chain in Norway, so it's a lot of security. We need to check all of our dependencies. So Sneak does a really good job. And ArcUnit. Are you familiar with ArcUnit? Are you happy with that? I'm really happy. So I can say that my life has my career has two parts. Before ArcUnit, then it's a line, and after ArcUnit. When I saw this tool, I just fell in love immediately. This is what I needed. Yeah, because I was tired to explain the same things like all the time, over and over again. So as you can see, we can actually automate some conventions inside our project, just writing simple tests. As you remember, we wanted to put conditional annotations in auto configurations. Is it easy to forget to put conditional annotation? Yes, it's easy. Is it easy to spot this during code review? No, it's not that easy. We usually take a look at what inside a method. So this is the automated way of checking it. And as you can see, it has as well some functions like as, where you can define the rule, and because, where you can explain why is it so. One more example, controllers are annotated with open API annotations, which is as well a nice thing, just to automate it. And one more, code is free of package dependency cycles. Is it easy to spot dependency cycles? No, our brains don't work like that. This is automated way of doing it. So ArcUnit just serves like three main things. So first of all, it's a huge time saver, because you as a developer can get feedback just on your local machine when running the test, and this test usually runs for like a 1.5 seconds for the entire code base. It's really fast. Yeah. Then during code reviews, you don't need to spend time on verifying some boring stuff. Then it's as well, it's a good tool for knowledge sharing, because this is how you can share your conventions, your approach to software development. Really nice. And the third one is kind of partially joking. Just a question to you. Let's imagine you put a lot of effort to write some nice documentation for your colleagues, maybe in Confluence or README file, and then in Teams or Slack, you just write the message. I wrote this nice documentation about this and that. Could you please give me your feedback? What is the common feedback? Or someone do this as well. And this is the way, as you can see, you can include the link. So the link will be clickable in your IDE. So they will click and finally read it. Your nice documentation, yeah. Just, joking, but partially, yes? So really nice tool. And this is how you can, basically in our case, in Java Libs, we define just a set of classes, each maybe from 50 to 100 lines long, really like a short test, and client project can just use it like this. Just I want to use standard tests, call this free of cycles, Spring test, domain-driven design test, CQS, and web tests. That's it. Everything is automated. Good. Documentation. Everybody likes reading 10 pages long documents. That's why let's talk about it. So we would like to make sure that people can find documentation, first of all. And we put some information to README files when it comes to technical concerns related to a specific module, or to Confluence as well, which as well can be an entry point if someone is curious, like, okay, where to start. Should we follow the dry principle in the documentation? Not that strictly. I think, my opinion, that we shouldn't. Because people may come from different places, and they want to follow and understand what's your library is about. And in this case, probably you should. Sometimes you have duplicated documentation. Yes, it's maintenance cost. You need to support it. However, you need to create as well a good developer experience. And sometimes it's okay to duplicate some parts of it. Cross links as well, from Confluence. From Confluence to README file, from README file to Confluence. Just sometimes it's okay. Just create a good experience. However, this is a price to pay for your convenience, just to additional maintenance. README files. Make sure people can navigate through multiple README files using some links. It shouldn't be like, oh. This is this, and you can read about it in that project. It should be a link to that project. Or this can be found in this module. There should be a link in this module. Yes, not just free text. It should be just create a good developer experience so they can navigate. Imagine that your documentation is read by junior developers, which means that we have a lot of assumptions about what other people know. And sometimes we just write, you just create this resource or something like that. How to do that? Yeah, so just maybe, again, supply with some information with some links, maybe just a quick note or something like that. You just don't put too many assumptions to your README files. And supply documentation with examples and guidelines. So we are not like, Apotec one is not Spring or other companies, so we don't have like time for writing very long documents, but it should be just enough to provide some guidelines and examples. Next one, making changes and some general tips. So making changes should be straightforward for contributors. So people will contribute in your common library, and the structure and the other guidelines should be there, and it should be comfortable for people to help. Avoid long and complicated routines unless you want to work alone. So if you want to work alone, just put these huge guidelines, everything should be manual and things like that. Then you will be alone. Nobody will disturb you, all right? Yeah, but we would like to, everybody will contribute, so that's why we don't create those long routines. By the way, do you know any good kind of recipe how to check if your guideline can be followed by others? Any ideas like how to check if, yes? Create some joke, okay? Maybe I will consider it, thank you. Yeah. Anyone else? Just. So let them follow the guideline alone. Okay? What's our like a common situation? You sitting just or standing behind and orally just commenting what to do. Okay? So that's a common situation, right? So we should just, okay, this is the guideline, could you please run it? If you have any problems, then we will fix it together. So fix the guideline if people can't follow them, and if it happens, it's your mistake, not theirs. So sometimes people just stop, they can't follow the guideline, they tell about it, and then your reaction is, but I wrote this. Can you read it once again? People read once again, then again, mistake. Oh my gosh, I'm so irritated. I wrote this. Can you just go and read it? It's not their problem. It's your problem. just fix the guideline. Just make it understandable for others. I think, does it ring the bell? Have you heard this? I wrote this. Yes? So, yeah. So just prefer good guidelines and immediately fix if something doesn't work. If they can't follow, it's not their mistake. Versioning. We don't follow semantic versioning. However, it looks like semantic versioning. So we have major versions. When we roll out some major updates, like for example, migration to a new JDK, or maybe migration to new versions of Spring Framework, major versions, something like that. So we change the major version. However, when it comes to minor version, we also can include the minor version if just some maybe little migration is required. So in this case, we change minor version as well, because otherwise probably we would have major versions number 34, and it just doesn't look great, right? So that's why sometimes we change our minor version as well. If you will go to the semantic versioning documentation, you will see a lot of words like must, and it's not always must. Sometimes you just need to apply this device and just apply it accordingly to your context. And the patch version as well, we don't use incremental versioning. We just paste the build ID. the build number as a patch version. So we can just easily track it. However, if you go to semantic version, it will say that it's a metadata, and it should go like a patch version, then dash, and then your build ID. But in our case, it just works better. So why not doing it? Yeah, maybe in your case, you will need those metadata. I don't know. However, just in our case, it's just fine to use build ID as a patch version, because it's incremental anyways. Documenting the changes. Again, we don't use any tools like some automated tools that will grab your all the changes and will generate some files, and you need to patch it and support it and things like that, migrate to it. Instead, we use a changelog. Are you familiar with the changelog format? Okay, yeah, quite a few. So this is just a nice tool describing like how you can document your changes and fixes and things like that. And with help of AI, it works really fine. Just describe my change. Just take a look at this file, changelog file. Describe my change from my current branch, and we just add it. Really, just easy. You don't do almost like anything. Just commit the files, verify, of course, and commit. And supporting old versions as well. So let's say we want to migrate to a new major version, and then kind of common sense says that we should create a new branch because we need to support major version, because not all the projects are able to migrate to the major version, to the new one. Again, we don't do this. So we don't support multiple major versions. And why? Because we chose another approach. We just constantly upgrade all the projects. So want to use a new version of Java Libs? Upgrade your project. Do you know the kind of a good motivator that works for us is Sneak again? It works like a kick, because when a Sneak pipeline fails with a critical vulnerability, our company policy says that you have to fix it. How do you fix it? You upgrade your project. Okay, so everything just works together. We decided to constantly upgrade our projects. Not to just to sit behind. And as a result, we achieve simplicity at the given capacity. Works really, really well. Just we don't need to think about all those branches for each major versions. Let's imagine we have implemented the change. Can we just ship it? So we have made a change in a Java library. Java Libs, should we ship it? In our case, a successful build is not enough, and we decided to create so-called reference projects. So reference projects, like a Spring Boot single module, Spring Boot multi-module, those depend on Java Libs and kind of verify that it actually works with semi-real application. And sometimes you make some change, your code quality is good, your tests are good. However, when you run everything together, something fails. Because Spring maybe changed something in their configuration, just deprecated something, and when you just combine all of those dependencies, it fails. This is how we check that our changes work fine, or we just reduce the possibility of not working changes in real projects. So when we do a commit in Java Libs, we as well adjust reference projects and build them and run them. Reproducible builds. Unreproducible builds is anti-pattern, correct? Correct. As you can see, we are guilty. We define our versions of Java Libs as version range, which means that we don't have reproducible builds. Correct? Because all the time a new patch version will be picked. So potentially our builds are non-reproducible. In this case, I like to say be pragmatic, not dogmatic. So, do we have reproducible builds? No. Have we gotten any problem during 3 years? No. Okay, so sometimes you can just do this and there won't be any harm. Maybe in your context, if you commit like to your common code all the time, just commit, your code quality is bad, maybe not good, and you just continue committing, and then your client projects may fail in this case. Maybe in this case you need specify specific version, okay? But in our case, if we specify the specific version, so for every change in Java libs, we would have to address all the project and fix this version each time. We don't want to do this. We want to do this to achieve this functionality automatically. That's why we use this anti-pattern, and it works fine for 3 years. And I think that will be the last one, forcing or advertising. So how to spread your ideas about the shared library. So you have like a couple of options. The first one, to force it. Like, you have to use it. In corporate environment, it works really well. Yes? Just add a new policy, and it will work fine. Anybody working in corporate environment with strict policies? Does it ring the bell when someone just defines some policy and it goes like down on the through the hierarchy, and then it goes back like yes, we use this policy. Yes, we use this policy. Yes, we use this policy. Everybody lives in illusion of that policy works, but in the real life, what do we have? Black market. So you know the right person whom to connect and write direct message, who will fix your problem instead of following the long process. Yes? Black market. So this is like a kind of consequences. So we prefer advertise the library. So because we want to understand whether it has good quality and demand. So if people want to use it, if we let's say experience, or if we observe some rumors about that is good, it works well, then it means that, okay, so we have done a good job. However, if you force it, then you will live in illusion of a good job done. Okay, you will live in illusion. If you like to live in illusions and think that, oh, I'm so good architect, I created so nice library, it's used by 10 projects, everyone is happy because they say so. It's your choice. It's your choice. So, conclusions. First of all, make sure you need a shared library, because maybe you don't need. Don't include anything unnecessary. You remember those 4 things, starting with the business and your expectations and willing to help, things like that. Create a stable, understandable structure. It's really important to put kind of a lot of effort in the design, because then it will be just harder and harder to change the design. So it should be like, you should think a lot about it. I remember that I did something, then I took a walk, took a shower, new ideas came to my mind, I went back, just deleted, discussed with others. So it should just give it some time. Help people navigate and contribute via well-written documentation, unless you want to work alone at this project. And choose the easiest versioning strategy. So please remember, you shouldn't follow all this must. Just think what suits you best. And if people want to use it, then you can say that you have done a good job. Thank you very much. Huh? Yeah. Yeah, we have 5 minutes.
Thank you very much for the presentation also.
Thanks for coming.
Okay, yes. Just one question about the conditional necessity for the autoconfig. Okay, I did some autoconfig in my life, and okay, sometimes I put directly the configuration, the auto configuration, and it works. Okay, we use it, and fine. Why it's so necessary to add and to use this conditional on autoconfig? So sometimes I just hold it.
Okay,
Thanks.
I'll try to open this slide once again. Just 1 second.
With your nice arc test.
I think this one, yes.
No, I speak about the rule of we have to check that there is conditional on
Arc unit.
with your in-log stuff. Because maybe I missed something. Yeah,
this one.
Yes.
Yeah. So why do we want to check the conditional? Is that we want just to make sure that this bin will be created only in the case when there is nothing in there, because sometimes like if you redefine it, then it will be skipped, and if you just define it without conditional annotation, as I remember, if you have multiple bins that is produced with the same type, Spring can bark on you. Because you want to have only one bin of a certain type, yes.
So let's say that it's best practice, or okay. So let's say that in this case, it should be. We must do it. We must do it.
Yeah, it's kind of avoiding errors provided by Spring when your application is starting. Okay. As well, if you have the same names as well.
Avoid multiple things. Okay, thank you very much.
Yeah, no problem.
I wonder a little bit about the ownership of this library or this common library. How do you deal with that? Are there multiple teams owning it, or is it just one team? And how does it work in real life?
Yeah, thank you. So in our case, we don't have a dedicated team that supports it. So basically, it's like any developer can go and contribute. Like in reality, it's like 3-4 developers. And we don't actually change it that often, because we just try to keep it, like a contained as little code as possible. So the main purpose is just to provide some common abstractions and help, rather than create it as a side project and just constantly develop something there, right? So that's the thing. Just some people, but anybody is just can join.
Hello, thank you for your presentation.
Thank you.
A quick question concerning commit changes. You told about reference project, but when you commit after that, you have to maintain this reference project. So one day you can see that it's passed for reference project, but actually it's not reference anymore, and you have a burden to maintain it. Is there any other alternative not to use reference project?
Yeah, so the reference project is not only, in our case, the reference project is not only the way to check how the changes in Java libs work, but this is as well like a default template for our services. So if you start with a new service, so basically you grab the code from the reference project. So we have to maintain it. So it's always maintained. So we don't forget about it. Yeah, so it doesn't go behind the Java libs. It's like a project, so it's just it's updated all the time. Yeah, and we use as well like a Jira. Yeah, we have Sneak. You remember the kick. So whenever it fails, we have to update it, and we have a Jira automation as well. So it periodically creates new Jira issues. Just upgrade this, upgrade that. I hope this answers. Yeah. Last question. 10 seconds.
Thanks for presenting. One question. Usually, if many clients, where I work in, the Confluence with the time become a mess, do you have any advices to keep the Confluence clean? Because with the time, it's harder to find the information in Confluence because there is many pages and people are not happy with reading the documentation.
I know your pain. In our organization, we have so many spaces and so much documentation. So the Confluence, this is a place where information dies. Yes. I don't have like a. I think there is no recipe. It's just it's mostly like a people's attitude. I don't have any solution. You periodically should review your job, review the documents, let others people read them. Yeah, and actually maybe not put unnecessary stuff. However, again, it's a long conversation. Yeah. Thank you.
Or maybe you can try Confluence AI. Maybe it can solve things, but not sure. Thank you very much.
You can try.
Have a nice day.
Thank you.